Okay, welcome guys. So this is the famous results, and many people already prove, right? But I still want to take all the details and make a reference. So reference is come from Wikipedia. So but we can add some detail, right? So the result will be sum of the normal distributed random variable. So the result is that let x be y and y be independent random variables. They are normally distributed. So their PDF will be Gaussian. Okay, so let's say x is a normal distribution mu x sigma x squared. So mu x is a mean, mu x sigma x squared. So is the is what? Is the variance, and the mu y and the variance, and the z will be x plus y. Okay, so the z, the final result is z is also a normal distributed random variable. This is very non-trivial because it's not easy to see these results, and their variance is just their sum, and their mean is just their sum. Okay, so if you know, the easy proof is that using a so-called characteristic function. So let's provide some details. So the characteristic function for the random variable x. Let's okay. So 1 second. The characteristic function for a random variable x is a function of t to be defined to be expectation value of exponential I t x. Okay, and if x and y are linear independent random variable function, then phi x plus yt will be this guy, right? But you can see if x and y are linear are independent random variable, then I can factor out into 2, right? So it will become phi xt, phi yt. So it's that if you the phi x plus y will be phi x times phi y if x and y are independent random variable. So that means if we know that for x, this is our general for the normal distribution with the mean mu and the variance sigma squared. So phi x y plus t is phi x t times phi y t, and these two. And they are all the exponential, right? So combine the t part and the t squared part. And this is the characteristic function of the normal distribution. This is a new mean, right? This is a new mean. And this is a new variance. Okay, so this is the standard proof. Okay. And another is that using the brute force. So we know that z equals to x plus y has the distribution that fzz will be fyz minus x fxx dx. Okay, so from negative infinity to infinity. Okay, and we know that fx and fy are PDF, so just the two normal distribution with Gaussian 1 over square root of 2 pi sigma x, and exponential x minus mu x squared divided by 2 sigma x squared, and phi y is 1 over sigma 2 pi sigma y, exponential negative y minus mu y squared, minus divided by 2 sigma y squared. Okay. So the rest we can do is just put everything into this convolution and doing a happy integral. Okay, the first part of detail, this is just copy from wiki, right? But I just want to see this step by step. So the first term, this is the first two terms, right? So you combine the first two, we get this. So let's provide some details. And combine to exponential, we get this. Okay. And the rest you can do just expand it. So remember that what we need to do is integral dx, right? So that means everything need to in terms of x squared. Okay, so this term contains 6 terms because it has 3 terms squared, so 6 terms and 2 terms. So you expand it and combine it as the polynomial of x. So x squared has this, and minus 2x this, and the rest is just constant. So write all into polynomial of x. Okay, and since we need to do the integral dx. Okay, so you see this is like exponential minus ax plus bx minus bx minus c dx. So this can easily be done by just using the complete square. Okay, so let's provide a final detail. So the result is that this guy can be written as minus a x plus b divided by this, and then plus 4ac minus b squared. If you remember your high school results, okay. So this guy is basically negative exponential b squared minus 4ac divided by 4a, and the square root of pi over a, right? And then also from the Gaussian, from this famous Gaussian integral. Okay, this integral is so famous that you should remember. If you don't know, you can go back to my, you can go to my video channel, or I will leave the gamma function or other like useful integral you should have remember. Okay, so now we have a, right? We have b, and we have c, right? So you should just put it. Okay. And Wikipedia is very happy that it help you to write down all the details. So, but actually, if you see the Wikipedia carefully, then it's the same as why, right? Also, if you complete square, then right, you just change it into complete square and do the integration. So the rest is that you define this sigma z as square root of sigma I square, and write it this, and complete square. Once you complete square, then you will get some constant term, right? Get some constant term, and which is this, right? This is your constant term, and then you can check that the constant term is actually exponential minus z to something. So this term looks exactly as a Gaussian, right? And then this term, you do the so-called, you do our result, right? So this guy will be pi over square root of pi of 2 sigma x, 2 sigma y, sigma z square, and then you will see this term and this term actually cancel. Okay, so the final result will be this guy. Okay, so this term will be 1. Oh, sorry, it should be pi over 1 of this, right? Because this is so now a is be 1 over 2 sigma x, sigma y, sigma z squared. So exponential minus ax squared dx will be square root of pi over a. So you let a to be this, and then you put in, then you will see this guy is exactly this guy. If you take a square root, so all this term become 1, and the rest will be this. Okay, so this is the detail of the brute force proof, and all the important idea is this identity, basically complete square and use the Gaussian integral. Okay, so I use a true proof to prove this normal distributed random variables, because detail is already given online, and you can find it everywhere. So I just want to make a video to provide some details and make a record. Okay, so please subscribe to my channel. I will see you guys in the next videos.